Hey guys, welcome back to AlgoYogi. We are doing graph series and our next problem in the list is shortest path with alternating colors. So let's go to LeetCode. So you are given an integer n, the number of nodes in a directed graph, where the nodes are labeled from 0 to n minus 1. Each edge is red or blue in this graph, and there could be self edges and parallel edges. So basically there could be multiple edges at the same time. That means there might be one red edge or there might be a blue edge. Now you are given two arrays, red edges and blue edges, where basically red edges at ith position has a pair that represents source and destination. So there is an outgoing edge from A to B. Now the same applies to the blue edges. Now we need to return an array called answer of length n, where each element at answer, let's say x position, is the length of the shortest path from node 0 to node x. So the source node is 0 and we have to find the shortest path from 0 to all the other vertices. But there is a catch. The catch is such that the edge colors alternate along the path, all right? Or -1 if the path doesn't exist. So there might not be a path, or there might be a path but like not with the alternating colors. So then also we can't basically find the distance. So that's where we will return -1. So let's go over this. I have taken a better example right here. We have basically 4 nodes, 0, 1, 2, and 3. Then I have taken some 2 red edges and 3 blue edges. So now what we need to return, if you go per the definition of basically our answer, so we have to return an array called answer that will be of size, basically the number of nodes, and at each node's position, basically this index, you need to return the shortest path from the node 0. This is the source, so this is our source 0 to all the other vertices, the distance from 0 to rest of the destinations. But basically the first time I saw this problem, I was like, oh, we gotta use Dijkstra. But I realized something, that if you are given basically, if you're not given the weighted edges, and if each edge is basically of same weight, that means that you're just counting the distance as in the number of edges to reach from source node to a destination node, then most likely you are not going to use Dijkstra. Always remember that. Like most of the time, just try to think of breadth first search. That's like my observation, but like definitely, think BFS before Dijkstra. So now as you can see right here, so if I'm trying to find distance, so okay, let's see. Let's do some dry run. So our source is 0. From 0, what I can do right now is I have 2 neighbors, right? 1 and 2. 1 and 2. So let's say to reach 1 from 0, what's the edge that I'm going to take? I'm going to take blue edge because that's the only edge going, right? Right now there is only one edge going. Although there could be another edge, red edge also parallelly. So in my red edge right here, as per the definition of the problem, we could also have this. We could also have 0 to 1. And remember, this already exists right here as well. So this can exist in blue and red both. So since I have not taken any other color previously from this position, if I'm trying to visit some neighbor of 0, then I can choose any color, right? So initially we can track that I have not chosen any color, so I can choose any color, either red or blue. But once you have chosen one color, let's say now you are standing on the vertex 1. From here, if you came choosing red and you are standing on 1, then next you cannot take red again. So you cannot take this one. You can only take basically blue and find the shortest distance to reach 3. All right. So now the shortest distance till 1 from 0 is going to be 1. And you can choose that you have taken whatever color you chose. We're just doing a dry run. We will dive deep into BFS just in a bit. So here, this is what we're going to mark. So 1. Then from 0 to 2, there is only one red edge. So then also this is also going to be 1. How about 3? So from 3, let's say if we chose red then we could choose this blue. If we chose red, we could choose this blue, and then after choosing blue, we can say to reach 3, we traveled basically, the distance would be 2. And also, I forgot to mention that this distance was 0. 0's distance to itself is 0, and then 1's distance was 1. Now we have calculated this. But remember, what if we took basically the distance blue here? If we chose blue here, then we cannot take blue again, this one. So we will take red here, we will take red, this one, and then we'll take another blue. So this will be 1, 2, 3. So this distance would be 3. But actually, since we are running BFS and we are going to use a queue will actually call blue and red, both of them, because we will be not just calling just the neighbors, but we will be calling on both of these since we have not chosen any of the color yet. So first time when you are basically trying to reach the neighbor that has both color edges, both blue and red color edges, then you will be calling all of them, and you will see how we will use 2 for loops to basically check that if the previous color is red or blue, and depending on that, initially you'll be executing both of them, but later you will check which color did you call previously, and then what color you need to choose next. So now this is the answer that we will be returning. So now let's get into how we are going to actually get this answer. So we will use BFS to solve our problem. So in BFS, we will need a queue, and this queue will initially start with our source basically 0, and then the length to reach 0, that's also 0. So this is basically the source, this is the length, and here we will initially have none, and let me tell you what this none is. So this is the color, previous color, let's call it previous color. All right, and then we're going to have visited set. All right, so we'll have visited set right here. So this queue now will start with 0, and then while queue we will basically pop the first value. So that this would be we can call it node, then you can call it length, and then you can have the previous color, and you will basically pop. So q dot pop left. Okay, you can see it. Now, like, I just want to have this basics clear that this node right here is your source, this is the length, and this is the previous color. And if this right here, this node basically is the source item, and this is not initially, it's 0, but we will basically, to find the distances, we will have to go through the multiple or single, multiple, whatsoever other nodes to reach to find the shortest path to the other destination nodes, because they're like, if you are starting with 0 here, then to get to 3 you're going through 1 as well, right? This is what I'm talking about. So now from at this position, what we are going to do is we're going to check what has been the previous color, and based on that, so here if the node, basically the color, let's say this color, previous color equals to red, or maybe let's say it's not red, it's not red. If this is not red, then you can execute red, right? So now it's none, but it's going to execute this. So for neighbor in basically, so using these red edges and blue edges, we will create basically their own graph adjacency list. I forgot to mention that, but like I guess like so far we already know, like those are our first basic steps. So we will create 2 adjacency list, so that we can easily access the neighbors of basically the neighbor in because we are executing red. So red, and we will provide this node. So this will give me all the neighbors that are reachable using red edges from this node. So all the neighbors. And so at this position, what I'll do, if this neighbor is already not visited, so if this neighbor, and I'm gonna say this neighbor and color. So here I'll mention red. So red not in, so you can't see it right here, so I'm gonna just bring it down, its size down a little. Yeah, awesome. So if this is not in visited, remember, because you want to have the color as well, because this neighbor might have been in visited with blue color, but this time we're just checking with the red color. If this is not in visited, then I will add, so add to visit right here, and then also append this to your queue. So queue dot append, and here you will add this neighbor, and then you can add length. Length would be basically the length here plus 1, so length plus 1, and then here this will be you can't see it again, but just remember we will be sending in red, because I've seen the same thing, this thing right here. I will be doing once more. So just remember, I will be doing this once more right here, but for blue color. Okay, so for blue color, so this will change to blue, so blue, and then this will also change to blue, and then this color will also change to blue. Okay, just remember everything here will be changed to blue. So now what we are really doing is, and this will also change to blue, you can't see it, but this will also change to blue. Okay, so what we are really doing is we are keeping track of previous color, and we are adding things to our visited set with the color, all the nodes that you have visited, and depending on the previous color you are choosing to take the opposite edge to reach your neighbors. So what I meant is, let's say if we were starting from zero, and to reach 0 I have not chosen any color, and my distance, my answer would be, and remember this answer I'll keep filling, I'll keep adding this to my answer right here, you know, whenever I'm visiting these nodes. Or I could just I can actually add it right here. So this node right here, I can add like my answer, and this node, to visit this node, so node, I will add this length. Okay, so this will give me my answer. This will keep filling the answers because I'll be keep popping from the queue. Now just remember this will keep filling. So 0 would be 0, it will fill right here, and then from 0 I have not chosen any color, but let's say from here I will visit this one using blue and using red both, and this one only red. Okay, so I will do that, and then once I'm here, so I have executed basically from 0 to 1. I have executed this one as well as this one. So that means I have appended this node 1. So that 1 is 0's neighbor. So 1, then length would be basically 1. Initially it was 0, and then I have appended red color right here, and I have done this one for blue. Okay, and I will do 0 just red because there is only one edge going from 0 to 2. That is right here. That is right here, 0 to 2. So now at the end, after this runs the pseudo code, it will fill up my answer. Basically, if it were not able to reach anywhere, initially we will initialize this with -1, and we will keep overriding everything. All right. So I think I guess it was easy to understand, and the code is going to be it's simple, but it will be like a lot of code, and that's because we have two edges array, and we will create let's say we're going to create red graph. Initially let's call it default date of list, and then we'll have, let's call it graph actually. So red graph and blue graph, that makes more sense, right? So now we'll have blue graph. So blue graph, let's populate them. So for let's say source and destination in red edges. So let's populate the red graph first. So red graph's neighbor of at basically source will be, we will append all the destinations. Okay, remember we are appending. Source could be common, so because it's a directed graph, we have to append it. Now we'll do the same thing. We'll do the same thing for blue edges. Same thing for blue edges, and let's fill it up. In my blue graph, I will do the same thing. All right, so now both my basically this graph adjacency list is done. We are ready to traverse the graph. Let's create Q. Let's create big Q. Initially this big Q, let's call it this time, let's just have it DQ. Okay, now this DQ is going to have three values. First will be the node. Initially it will be 0. Second will be the length. Length will also from 0 to 0 is 0. You can call it length, you can call it distance, whatsoever. We can call it distance from 0. So source is 0, just remember. So source is 0, and then we will have distance, and then we will have basically the color, previous color you can call it. So right now my previous color, I have not chosen anything, so none could be a default value. Then I will have visited set, so it will just be set. This will just be set. And in the beginning, because I'm adding it to my queue, I can say that this so that I don't come back to it, I can say I can add it to my visited set. So visit.add, and what am I adding? I'm adding 0, and from here I have not taken any color, so I will actually just mark none, honestly. Okay, now what do we do? Also, let's create the answer array. Initially, let's initialize it with -1, and let's multiply it with n. That's the result we will be basically returning. Now the common thing of BFS is basically while q, let's pop the first value, topmost value, or the very first value that we just pushed in right here. That will give me 3 values. So I can say it will give me u, the source. Then it will give me the distance, so we can call it distance, and then it will also give me the previous color, so prev color. So q.pop left, and now what do we do now? So here let's populate into our answer. So answer at you can say u is now we are using as index, so we will put in the distance. But once you put in the distance, what do you want to do? You want to explore the neighbors. So if previous color is not equals to red, let's call it red. If this is not red, that means I can use red edges from this current u, basically source node, to all the other reachable nodes, which will be neighbors, using the red edges, so using the red graph. So I can say for neighbor in red graph, from where, or what are the neighbors we are visiting? All the use neighbors. Okay, all the use neighbors. So now these neighbors that you are seeing will be from the red graph. But do you want to visit all these graphs, all these neighbors? Well, first we have to check if this neighbor and this color, which will be red, if this is not in visited, if this is not in visited, then I can basically add it to my queue and also add it to visit as well. So this neighbor right here, I can add it to my visited set, and then I will append it to my queue, because now I can choose it to basically visit all the neighbors. So queue.append, and just remember we were appending 3 values, so but we are appending it as like, this array, or like you can call it tuple of 3 values, but I put it in basically a string, this array format. So now this will be the neighbor. Next will be the distance. So distance would be previous distance that I have just taken to reach here plus 1, right? initially it would be 0, but to reach its neighbor I'm choosing to take that edge, and we are counting edges here. And now this color will not be none, this color would be red. This color would be red. The same thing we are going to do with blue color. So blue color. So if this color is not equal to blue, previous color is not equals to blue, we are going to visit all the neighbors reachable from the source node using the blue edges. So I guess you guys already know that this is also we are planning to change. So all the neighbors in the blue graph from U that are reachable, and then finally you will be coming out of this this queue after visiting all the nodes using blue edges, or the combination of blue and blue and red color edges. So just remember, from previous we are pushing here red, and here we are pushing blue. So at each node that you just visited from 0 as being source node, now you are visiting these neighbors. These neighbors will carry alternating colors with them. So here, once you come out of this while loop, you will have your answer ready, because we are pushing this shortest distance, and we don't have to calculate the minimum distance, just like we do in Dijkstra algorithm. Here you have all these edges of unweighted edges, so the distance is basically we are incrementing by 1, so which is getting assigned, pushed into the queue, and then later you're popping that distance and putting into your U. If that was not reachable using these alternating edges, that means like you already have the -1, which has been asked in the problem to return. So here you can just simply return answer, and I guess that will be it. So let me zoom out, and then we can just go over it before we run and test. So default, so this is default dict, not default dict, same here. And then I think in DQ you provide in this as a tuple, so that's how you access it, because this is an element and it goes in with the array that is basically given to the DQ, because DQ itself is the inbuilt data structure, and you're giving us this this array Q. You could simply have just Q. I like to do it that way in this case, but like DQ is more efficient. So that was one thing. Also, if you see right here, we are overwriting the distance at U again and again, even though we might reach it later from some other node. We don't want to do that. If this is basically is equals to 0, equals to -1, because that's what we have initialized it with. So if this is -1, that's only you want to overwrite it, because that's when you reach it for the first time, and that's when we want to overwrite it. And I think that would be it. And let's make these little consistent. We are adding it as tuple. We just changed it, right? So we want to change this as a tuple also. And I guess now we are all good to go. That is our entire code. So I'll just run it. And awesome, let's submit. Great, so let's write down the time complexity. That would be, time complexity would be, so we are kind of visiting it like all the nodes, so n, if there are n nodes. But if you remember, we are actually at times, although there might not be the edges, what worst case from one node to another node, you're kind of going like twice because of red and blue edges. So it will be 2 into n, which again comes down to n. And then for space complexity, we have these two default dictionaries, so that will be, you can say v plus e because it's a directed graph, but I would rather just call it like big of n as well, or 2 space complexity. 2 into n, that is also is going to be n. N is the number of nodes. Now that is it. That was it. Yeah, you can see it. Now let's go back to AlgoYogi, mark this solved, and see you guys later in the next problem.